Okay, 4 is a good place to start. So here we go, 4 in the yellow. What is the average value of y for this curve in the first quadrant? So what we did last period is we first went to our calculator, went to y equal, clear this off. Someone raise your hand and just read to me the equation in number 4, please.
3x minus x squared.
Deborah says 3x minus x squared. Points for Deborah. Somebody just raise your hand and tell me. It says we're supposed to find the average value of this function right here. The average value of this function in the first quadrant. So I always type an equation and then I always hit window. Someone tell me what would be an appropriate choice for a window in this case. Chen?
0 to 5.
0 to 5. Why 0 is a perfect choice?
0 because if you go further left or further negative 0, you're out of the first quadrant.
Nicely done. So Chance remembered this, that if I'm looking for the first quadrant, the quadrants are numbered like so. 1, 2, 3, and 4. So x equals 0 is where you want to start because that's where the first quadrant begins. He guesses 5 because he remembers well that I said that's a good guess if you're not sure. 2 for Chance. Then we do a zoom fit. We're trying to find the average value of this function in the first quadrant. Someone else pick up 2 tickets and tell me what would you do now? Here, please.
I would just do change the window 0 to 3 because what we just know how.
Oh, very good. Just kind of a caution. Always make sure.
Yeah.
It definitely looks like 3, but you want to do something to confirm that.
I did it.
No worries, Sarah. Perfect. So I say second, calculate 0, left bound, that looks good. Right bound, I don't like to drive the cursor, it takes too long, so I go 3.5. Now I've got it bounded. It says guess, I'll do Eric's guess of 3. Okay, perfect. Because this comes out without any decimals, you don't have to store it. Just remember it's 3. Over here it appears to be 0. It would be probably wise to check it. It won't find the 0 though unless you go a little bit past. So you've got to change the window just a little. Say -1, zoom fit. Does there have any follow-up questions? We're going to pay to have the homework done on Wednesdays, so make sure you ask about anything.
Well, it's with the calculator, because you said you teach us how to store on the Inspire bit.
Oh, no worries. So get it powered up.
Okay.
Don't say okay and look at it.
Come on.
Yeah, very good. So get this graph. I'll show you. So while he's getting it graphed, I'll just check the other 0 real quick. I don't know, about -0.5 and 0.5. It's not a negative. 0.5 looks good. The guess is 0. And sure enough, so we're good there. So we'll just keep going, Chad. You're good.
I have a question.
Please.
So like on the AB test, you know how they have like how to store it in your calculator? If it is that like no decimals at all,
You don't have
they
to
don't
store.
like you don't have to write like
No, no.
They just-
So like when I find the 0 is an exact value of 0, I don't worry about storing.
they
You
don't.
don't. Never.
Is there like questions that are not FRQs, do we have to store them?
You do not. Multiple choice, all they're going to do is run your Scantron. So. What else? Chad, did you get it graphed?
Yeah.
Perfect. Did you get it to find the 0?
I will right now.
Good man. And anyone else who has an Inspire wants to know how to store. Got it there?
Yeah.
Cool. So it's showing on the screen the value, right? 3, 0.
Yeah.
So this one we don't have to store, but here's how you would.
Yeah.
Use the cursor and get it so it has the little hand thing.
Yeah.
So it's pointing to the 3. Click once. Did it highlight the 3?
Yeah.
So the 3 alone is highlighted.
Good.
Now press the store button is Control, and then you see the store. Yeah, do that. It's now asking for a letter.
Oh, yeah.
Just type some letter, press Enter. Now just go back in there and hit C, and it should be the same. There you go. That makes sense. You're welcome. Sorry for teasing you about this. No.
Oh, it's alright. I think it's
2 tickets for abuse.
Yeah.
Okay.
What?
Minor, but you know.
My favorite use.
Wasn't really, it's
I'll
just
take
teasing a
it.
little bit. I felt bad.
You don't feel bad.
Okay. You have a question in here. Raise your hand if you need me to keep going on this problem, otherwise we'll say that you understand it. So we need me to keep going. Glad to keep going. So then we go back to here and note that they said find the average value of the curve which is in the first quadrant. So the only portion of the curve that is in the first quadrant is from 0, x equals 0 to x equals 3. Here's x equals 0, here's x equals 3. So we're finding the average of all these y coordinates. So I write that down. Find the average value of this from 0 to 3. And I remember, I have memorized that to find the average value of a function, I integrate whatever I am averaging, and I divide by the width of the integral. So now I pick up my calculator. The integral turned out to be 4.5. I would do that here. I just go back to the main screen, second quit. There. And that's not the one I want. This is the one I want right there. I can scroll up and find it without having to retype it. I want to go from 0 to 3 in y1. Just press enter. Press enter again. The value of the integral is 4.5. So back on my paper, I wrote that down. Divide by 3 is 1.5.
On your calculator at 4.500, does that mean it's not exact? We use 4.5.
Really good question. I'm not sure. Let's find out. So I go to mode, and I change this to float. Go back to second quit. Grab it. Again. That one turned out to be 4.5. I think they're showing decimals because they know it's an approximation. And it may be 4.5 to as many decimals as can be displayed,
Yeah.
but the numeric value that is stored internally is actually larger.
Yeah.
So if I were taking the AP test and it wasn't multiple choice, I'd write down 4.500 just to be safe. The thing that helps, Chad, is most of the time on the AP test, the problems you do with your calculator don't come out to be clean anyway, so there's not really a question. Please, sir. 2 points, good question.
When you're not finding like the average, so like the intervals on the first assignment, what does the answer like represent?
Oh, good question. So far, I give you 5 for this one, Sarah.
Wait,
Why didn't I ask that? What she asked was, what does the value of the integral represent? And quick summary, so far we have learned that the value of the integral can represent 3 different things. We've done problems, this was on the Buff worksheet. On the Buff worksheet, we did a lot of integrals that were always velocity multiplied by time. Everyone needs to memorize that whenever you integrate velocity over time, velocity multiplied by time, you're always finding the change in position of a particle or object or whatever. You need to memorize that. That's on the test for sure, over and over again, like heavily tested. My test and the AP test. When you integrate velocity, you get change in position. So the value of the integral represents how much the particle or object's position changed during that time interval. Does that make sense? Good. We also learned this one though, Sarah, that sometimes when we integrate, I don't remember the exact example, but we did stuff like this. These were integrals we were performing to find the area of some space on a graph. So we've used integrals to find change of position. We've also used integrals to find area. And then the last one is average. And those are the three uses we've had so far. And we'll keep adding to that before the test. Is that your question?
Yeah.
Perfect. So the average was like the one we just did. Asking again.
Are the two DXs
Don't ever stop.
going to be the same number?
Say again.
Are the two DXs going to be the same number?
The choice of dt or dx depends on how accurate you're supposed to make the integral. So when we did these computations on the buff packet, we were doing Riemann sums, where they make dt fairly large, but it would vary from problem to problem, even sometimes from subinterval to subinterval. So we're just getting approximate values for the change of position. When we were finding area, we were able to use our calculator most of the time. So dx is very, very small. This one we just did to find the average. We were using our calculator. Dx became very, very small.
Okay, but what about the dx and the dx equal for the average value? Is it going to be the same?
As for the area?
No, I'd like the same number in that. So like
I grab a few DXs.
yeah.
Oh! Raise your hand if you noticed that I wrote dx here and you didn't think I should have. Show me your hand. Fair enough. Fine, take it. Well, not for Derek, for the rest of you. Not for you. I was for being honest. 2 tickets for being honest.
Like, I know you're saying I just didn't pay attention
You're
to
good.
the formulas and stuff. I read it down.
I get the not paying attention.
See, if I did pay attention, I would have confused myself. But
True.
in the end, I
2 tickets. Okay. No, sorry, my bad. I just wrote it wrong. I got busy trying to keep track of everything. When you're finding the average, what goes in the denominator here? Yeah, n minus beginning. So this should have been 3 minus 0. Then you would not have had the question, right? Is that fair? No, good job. Don't stop asking, sir. Ever, don't stop asking. When you stop asking questions, the learning stops. Don't stop asking. I heard a story once of a teacher. This was told by another teacher. So actually the librarian, Mrs. Gardner, she was in like 9th grade doing in a geometry class when she was in 9th grade. Oh, that makes a lot of sense. You hear this one?
Yes.
See if I get this story right. I probably don't know all the details, but she told the faculty one time that she was in a geometry class in about February. Maybe it's the same story, I don't know. Tell me in a second. The teacher announced to the class, Sarah, from this point on, there will be no more questions in class. Serious. We have far too much material to get through. No questions in class. You want to ask something, you come after school. So, no, I don't like that. Please. The best, honestly, if I could get everyone to just be like super comfortable with just asking and asking and asking, the learning would really accelerate. The hardest part about being a teacher is I really can't tell for sure whether it makes sense to you or not. And so if I keep going on and on and on because I think it doesn't, and it already does, then I put you all to sleep, right? It gets really boring. But if I go too fast, you hate it as well. So you just have to keep fast. Any other questions here? Okay, cool, next one.
Okay, actually, I have
Please.
So, when I was going through the earlier packet that you guys had done, like the fourth booster, I was wondering like what units do on them.
Oh, no worries.
Units on these two, but, oh, I guess it says.
You're good. Everyone look up. Hey. Okay, the problem we just didn't have any units. So 2 points for Annika. If I forget, remind me. As we go through different questions, I'll show you the units on every one. And really, the units are the easiest part once what I show you makes sense. So it does make sure you guys. So we've done number 4. We'll jump to number 5. Okay, let's erase this. Sorry, Brett. Okay, number 5 is a review question. It's from Unit 1 and Unit 3. Number 5 is not a Unit 4 question. Number 5 is a review question. One person, please. Hey. So I have to keep blending them because we're driving towards the AP test. You can't keep things separate, so got to come together. Somebody tell me, they say find an approximation for W prime of 12. Just raise your hand and tell me, what does the symbol W prime of 12 represent? Bailey.
Tangent slope at 12.
Good, the tangent slope of what? W, perfect. The tangent slope of W at 12. So in Unit 1, we did this all the time. We remembered that you can't find a tangent slope from a table. So I look here, I'm trying to find the tangent slope of W at 12. So what I do to approximate that tangent slope is I find the nearest secant slope. And in this case, there are 3 possible ways. You can choose any of the 3 and you'll get credit. You could take the secant slope that's coming into 12, like from 9 to 12. You could take the secant that's leaving t equal 12, that'd be from 12 to 15. Or you could find the secant slope that surrounds t equal 12. That would be from 9 to 15. Any of the 3 are valid. If you look at the answers, they show all 3. That's not because you have to do all 3, it's because any of the 3 will count. So here's the answer to 5. You have to show your work. You have to show this, this, or this. Really good question. There are 2 tickets. You can write it like they did, Derek, or if you prefer, you could have written this. Just, you'll help me out there. What is W15? Just look at the word.
21.
So you can write 21.
Yeah, that's what I did.
Yeah, no worries. And then W12 is helping.
27.
We'll just keep going there for a second. And then you'd write 15 minus 12. And then you would have written -1 over 3. And that's perfectly valid. Now, Annika's question, units. It's really simple, Annika. Look at the paper and tell me, what are the units that belong with 21? Perfect. And the units that belong with 22? Also. So if you take degrees minus degree, this -1 is what units? Degrees. Just write down the units. And then, Annika, what are the units of the 15 and the 12? That's all you do.
Okay.
If you pay attention to where the numbers come from, the units for the answer are easy.
Okay.
So we'll keep practicing. Does that make sense?
Yeah.
2 tickets.
So there's 3 answers.
So there's 3 possible answers. Any one of them, Sarah, is fine. You don't have to have all 3. Just any of the 3, sorry. Does that make sense? Perfect. 2 for Sarah. Please, Chen.
So like, I don't know. When I was thinking of this, so you have your 2 secant slopes, but if you do like, I don't know, the secant slope of 9 to 12 and 12 to 15 does not be somewhere between the 2. Also,
Oh, that's very good.
That way.
Listen to Chance, but everyone look at the board. Everyone look at the board. 4 tickets. Very well done. Okay, he's remembering something that showed up on tests for Unit 1 and Unit 3. And that is there were problems where they were just worded differently. Like this one said, find an approximation. So there really were 3 ways you could do it. The ones the ones you're remembering are ones where they said, like, what could be the possible value of W prime of 12? And you had to figure out that it was between the 2 adjacent secants. That's perfect. It wasn't necessary here, but it does show up on other problems. It's perfect. Follow-up questions to that. Awesome. Another follow-up to 5 in general. Okay, next one, 8. So, a few people needed some review on Riemann sum. So we'll do a little Riemann sum review here. This is review from the Buck packet. So reviewing from the Buck packet. Okay, we're doing a Riemann sum of f, the integral from -3 to 15. They said make dt free. So I'm going to ask a lot of questions. If you raise your hand and answer, I'll just keep paying you 2 tickets for every time I call your name. So anyone can raise their hand. Just somebody answer this. I'm doing the Riemann sum of this integral. I must first identify the first subinterval. Someone, what's the first subinterval? From where to where? Deborah. So I go from -3 to 0. Get a pen. 2 for Deborah. So when I'm doing a trapezoidal approximation, I go to that first subinterval, and I pick the value of time on the left and the value of time on the right. Okay? So I'm going to take f of -3. I'm going to add that to f of 0. Oh, thank you. Somebody noticed the mistake? You good? So f of -3 plus f of 0. Okay, everyone look at the board. I can see your eyes up here. Okay, when I'm doing the integral, I'm supposed to take a single value of f multiplied by dt. With trapezoidal, it looks a little weird because you end up with 2 values of f, but we divide the 2 that are being added by 2 because that creates a single value of f. For the integral, you can only have one value of f times dt. You're simply finding the average of these 2. Don't confuse that with finding the average of a function. That's different. We're just finding the average of 2 values to do the trapezoidal sum. Please, Ellie.
Would it mess you up if you saved the 2 to the end and multiplied it by 1/2?
Hold that thought for a second. It's a really good idea, actually. Stay with me. 3 tickets. So we do this, and then we multiply by the dt. So someone please hand, what's the dt for this first subinterval? Let's go with Maddie. So we put down a 3 there. And we say plus, and we go to the second subinterval. Somebody, where did the second subinterval begin and end? Let's go, Ellie. So go 0 to 3. So someone tell me what to write here for the second term. Let's go, Haley.
F of 0 plus F of 3 divided by 3.
So f of 0 plus f of 3 divided by 2. And somebody else, what's the dt for this subinterval? Let's go here to 3 again. And we say plus, and we just put dot, 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 because it gets a little tedious to keep going. Anyone have a question? You simply do this for all 6 subintervals. Now, Ellie's question, let's go down one more line. Then you actually find the values. So somebody, what is f of -3? Hear your voice? Say it louder, Derek. 0. And then Derek, what's f of 0? We're having trouble. They both have 0.
-1, sorry.
Oh, there we
Look
go.
at the blue thing.
No worries, my bad. So all that divided by 2 times 3. Somebody else over here? Let's go, Bailey.
0.
Here's what Ellie noticed. Every single term, there's going to be 6 of these terms. Every term in the trapezoidal sum is being divided by 2 or multiplied by 1/2. So if you want, you can factor the 1/2 out and do it at the very end. Like get the result, multiply by 1/2. Totally legal. Because every term is being multiplied by 1/2. Is that what you mean?
Yeah.
Okay. And the 3 in this case, be a little careful with that just because they like to give Riemann sum problems on the test where the subintervals are of different widths. And then you wouldn't be able to. Yes.
Will we ever do them the way that you don't have to pay it if you don't have to pay it again, but we'll just or is it always just going to be
Oh, I've never seen a Riemann sum problem where you didn't do for several terms. That's what yeah. Follow-up question. Okay, two more for Deborah, then 1 second chance. Okay, one thing on the AP test and my test as well. If it's an FRQ, okay, as I said to Deborah a minute ago, if it's a multiple choice, you don't have to show work. If it's an FRQ and they ask for a Riemann sum, you have to show work. You do not have to show this line though. I've been showing this line so no one gets lost as to what's really happening. On your work, this line is sufficient, but you can't say dot, dot, dot. Okay. You have to show the 6 terms. Otherwise, you do lose half of the available points. Somebody else had a question? Cool. Do we have anything else on this one? Next one. So that was 8, 6. Basically the same question, pretty close. We'll start, I don't know how far we'll go. It asks for the average temperature in degrees Celsius of the water over the time interval. Then it says using a trapezoidal approximation. One key part of this FRQ is you have to write down the correct integral to begin with. If you don't write the integral, you lose points. So someone tell me, if I'm trying to find the average temperature of the water, the average temp, which they're calling W of T, for, it says the 15 days. So that would be T equals 0 to T equals 15. Somebody tell me, memorize it.
So we need to write all that, or we need to write average.
Really good question. I put more in the notes, of course, to make more sense to you.
Yeah.
In reality,
What do we need to like title our?
I know what you mean. In this case, I really like you doing equal signs, but in this case, I will make an exception.
Mm-hmm.
That if you just write the integral, it's good enough.
Okay.
It really
You're
is.
gonna label it with.
So, what's the integral there? Do you know?
Oh, 0 to 15. F of what? Sorry. Yeah, I don't know what I wrote.
So there's 2 points for Derek. Help me with.
Would it just be W of T multiplied by the interval of time?
Yeah, don't forget the dt. Perfect. Keep going, Lynn.
And then all that over the interval of time, which would just be 15 minus 0, right?
Nicely done. So 2 for Landon. Derek, your question on the AP test, if they say approximate the average temperature in degrees Celsius of the water over the time interval, they're going to want to see this, that box.
I just started doing. I didn't write down like the.
Okay. Yeah, they do want to see this. You don't have to have the words. Does that make sense? So they do want to see this right here in the box. You don't have to have the words. Then they want to see the approximation. So then I would come down here and I'd write, that got kind of big. So I say the integral from 0 to, now here's where you really do need to have some equal signs. This is going to be approximately. The 1 over 15 I can just leave out in front. So we'll just do a few just to make sure we got it. Somebody tell me, I'll pay you, what's the first term in the trapezoidal approximation? For the room?
So like 20, 30 stuff.
Let's do the W thing just to make sure.
So it's W of 0 and W of 2.
That's 2 for Deborah. Somebody jump in. Oliver and Bob. Go, Bailey.
W of 3 plus W of 6.
Oh, we need something else here.
Oh, divided by 2 times by 3.
2 more points for Bailey. Somebody jump in from there. Let's go, Lexi.
Plus 1 over 15.
Oh, so I looked that up front, so I'm good there.
Okay,
So.
W of 3 plus W of 6.
Somebody else jump in there. 2 points for Lexi. Jen.
Divided by 2 times 3.
we got it. This would be 1/15. Somebody tell me what this becomes. Ellie? So once again, on the AP test, you have to have what's in green. You don't have to have what's in purple. So let me just do the next one, please, Sarah.
Yeah, so 31
Perfect. 2 more tickets. We're good.
oh yeah, she's also
I know that's right.
oh. But so do you take that all since there's not an equation, do you take that all into your calculator? And since it's an answer.
On this one, because of like the answer comes to 25.1, which you add in 2 zeros at the end in the answer. So like the answer is 25.
Oh, gotcha. No, if it comes out perfectly 25 point whatever, you don't have to have extras. That happens a lot on Riemann sums because you're adding up nice even numbers. Please, Lindsay.
Why do you have the 1/15 out in front?
Oh, no worries. So to find the average of the water temperature, I have memorized that I must integrate the water temperature, W, and then I must divide the integral by the width of the integral to get the average. The Riemann sum part, so the part inside the brackets, Lindsay, that's only approximating the integral. So I still have to take care of the divide by 15. Multiplying by 1/15 is the same as dividing by 15.
Okay.
Good?
That makes sense, yeah.
2 points.
When can you tell when you have to divide the whole integral by the endpoint minus the start point?
That, I can never say the word all, well, hard to say always, because I don't want to fool you. But I don't remember any problems where that happens other than when you're computing some sort of average.
So only average problems?
So what happened was, Ellie, is they asked me to find the average temperature of the, okay, I wouldn't say average problems, that's a little bit too big. But they specifically said, find the average temperature of the water. So I remember, to find the average of something, in this case W is the temperature, I integrate whatever I'm averaging. That doesn't give me an average. What gives me an average is the integral combined with dividing by the width of the integral. Is that your question?
Yeah.
Good point. Anyone else? Well done. Next one. That was 6. Where? 3 on the peak. 3 on the peak.
You're gonna love life. You're gonna cry in my that would make me rich.
Yeah.
I'll tell you this.
Silence. Quiet. No one talk. 3 on the peak. Make sure you have this formula memorized right here. Make sure this is memorized. The area of any thin rectangle can always be found by taking the y-coordinate at the top of the rectangle, subtracting the y-coordinate at the bottom of the rectangle. Okay. The area of any rectangle can always be found by taking the y-coordinate at the top of the rectangle, subtracting the y-coordinate at the bottom, then multiplying by the width of the rectangle, where we let dx be the width. If you have a question about that formula. So whenever I'm asked to find area, that's the first thing I remember. I'm supposed to find the area of R. So all I do is I fill R with vertical rectangles. So there's a thin rectangle, draw some more. And I'm paying attention as I draw the rectangles to where the y-coordinate at the top of each rectangle is located and where the y-coordinate at the bottom of each rectangle is located. These are some sweet rectangles. Look at those. That's a nice drawing, man. It's like a tropical. Now you gotta feel it all the way in.
Yeah, you
You have the patience. Okay. It looks like a little pop. It looks like a popsicle rainbow. It's very nice. I do note this though. It does not matter where inside of R I draw these thin rectangles. The top rectangle is always hitting one function, and the bottom rectangle is always hitting another. Okay, everyone look at the board. Got your eyes here, Chad. Look up. Okay, look up. Okay, on the AP test, this is crucial. This is crucial. Okay, we're going to start doing FRQs on tests. You must write everything that the grader expects to see. So for example, I need to tell the grader that this graph right here, let's see, I could use my calculator to figure it out if I need to, but this is the graph of root x. So I have to write down. You can't just like draw little arrows here, you've got to write it in equal signs. F of x is equal to root x. You must tell the grader. You then note the other one. Got fish in the room. My son does a good cricket. He's really good at cricket. I whistle, but it's not really creative. Quiet. Silent. So I note this, look. I tell the grader this is G, tell the grader this is F. And I remember the y-coordinate anywhere along here can be found simply by taking the F function and plugging in whatever x I'm interested in. Therefore, any of those rectangles can be found by taking the F at some x, subtracting the G at that same x, and then multiplying by dx. So to find the total area of R, all I need to do is like 1,000,000 of these computations for 1,000,000 different x's. So give me one or two if what I just said makes perfect sense. Give me one or two if what I just said makes perfect sense. To find the total area of R, all I need to do, lost Ashley. All we need to do is, it's all right. All we need to do is do this computation 1,000,000 times for 1,000,000 different values of, lost Ellie. Oh no, she's just doing this, sorry.
Ellie.
Don't get on Ellie, she's always paying attention. She's taking time, you know. 2 points for the room. So I need to figure out the x value where this begins. So I would have to use my calculator to find this. I need to tell the grader what I'm doing here, so I go like so. This is x equal. Somebody, what did you find it to be? Somebody already found it.
0.239.
0.239. 3 tickets for correctly saying 3 decimals. You would have stored it somewhere, I'll say B. So we do this computation, f of x, subtract g of x, multiplied by dx. We do it beginning at an x coordinate of b. We stop at an x coordinate of 1. After we do these millions of multiplications, we add them all up together using an integral. The integral actually takes care of all of it. And that would give you the area. What area did you get, Kelsey? 4 for what?
3.
Thank you. On the AP test, they expect to see the integral written, and they expect to see the 0.443 if you want full credit. They would also have to see the f of x written out, the g of x written out, and you have to identify what b is correctly. So really, everything that is on the board is required. Other than this part here, you didn't have to write that. Sarah?
So would you write it like that? Is that like fine? Or you know where it asks like find the area of R down the answers, you need to put all those in the end?
No, this is fine. On the actual AP test, there'll be some space below. I just, to save some paper, I knew you could just fit it here.
I know you can't use like y1 and y2, but do you have to use f and g as a thing?
Good question. Hey, listen to Ty, please. Listen, hey. The rules of the test strictly say what you said, that you cannot use Y1 and Y2. So I'm a little nervous about using like F1 and F2 like the Inspire uses. I'm not sure if that's what you're thinking. F and G aren't required. You could use F and H or whatever. You could use Q. I'm going to use F and G just to develop a good habit. So, yeah. Please, Deborah. That's very well said. Everyone hear this. Hey, this is Q for Deborah. On FRQs, unless there is a statement that says something like explain the meaning or justify your answer or give a reason, you don't need any text. If it says justify, explain, give a reason, then you do have to write some words. No, it doesn't have to be a complete sentence. It doesn't have to be correct grammar. It just has to, and I'll show you when we hit those. We haven't hit very many of those yet. I'll show you basically what they expect you to write. So FRQ in calculus does not mean a lot of writing. Please.
So on FRQs, you know how you said they'll give you like a bunch of things to work with? Is it fine if we do, like, on this one, for example, put x equals 2.39 on the graph and then do our work underneath?
It is. I'll show you a little bit later, but this is pretty representative of what you'll see. On an FRQ, they literally have boxes on the paper, like I show you here. And the rule is everything that's inside the box gets graded. So the grader will look at everything inside the box, and the way he grades it is like this, Kelsey. He looks at this first and says, hey, they got the right decimal, so it appears they knew what they were doing. You get 1 point. He then looks back to the work and says, okay, I'm supposed to give 1 point if they have the correct limits. Well, he looks for an integral because you can't have limits if you don't have an integral. And as long as there's a b and a 1, he says, okay, what is b? So he looks back over and says, oh yeah, they identified b correctly, that's another point. So he looks for the integrand, that's this stuff here. He says, that's correct as long as they've identified f and g. He looks back over, yep, f and g.
So if it's in the box, you're just...
As long as it's written out correctly. Hey, listen, please. Hey. You get a bit of a catch-up day. Again, I'm going to be paying for completion. So on Wednesday, I'm going to pass the clipboard plus pay some extra credit. If you have fully completed buff, pink, and yellow, then we'll start brand new on the next time.